Hey guys, welcome here to our new representation of the NREC kit from K2 Systems. My name is Lars, and for everyone who doesn't know me, I'm responsible for the project department at K2. So in general, we are responsible for GMS projects, parking spaces, or some special sort of constructions. So as we realized, there several requests also for ground systems, for smaller project sizes, or even just for small tables for gardens or on farming sites. We developed a kind of easy, easy standardized NREC kit solution, which could be used in the gardens, in little farm areas, even for small size projects where it's pretty easy to design the whole system construction and to have a very good solution for the different foundations that could be used on different projects. So yeah, we want to keep something easy and fast in designing for you as a product to get via the distributors or even directly at K2. So today I'm here showing you this INREC kit solution, giving you an idea about how the kits are configured and how the application does work and the manual is used, because in this case we have a little quite more figure manual as on other systems that you know. This is just because we bring all the different sort of foundation solutions you could have with the kit inside of one manual. At the end, it's just knowing how to use the manual, and that's pretty easy. So I will give you an introduction to that, as well as an idea what does the kit not in standard cover but could be done anyway. I will come together with my buddy Vladimir today, who is in the training session area. So Vlad, yeah, say hi to the community.
Hello, everybody. My name is Vladimir. I'm technical sales at Q2. If you watch our webinars regularly, you probably know me. Right away, some rules about our webinar. So there are two ways to communicate with us: chat and Q&A section. So if you want to say something general, or if sound is bad, something else, please write it in chat. If you have some technical questions or questions related to our today's topic, please put them in Q&A section, because for us it's much easier to answer your questions from there. So, Lars, please proceed.
Yeah, great. So yeah, we're just jumping over here. So there you could see this is the NREC in general. So this will come up. Our kit was coming up with two parts. So we have the top kit and the grounding kit. Here you see the top kit of the NREC. So the top kit always include the bracings, the beam, as well as the rail profiles and climber. And there is then the grounding kit, which includes screws, nuts, and the fixation towards the foundation. So depending on which foundation is used, you have a different ground kit in the system. I will show this over there in the little presentation, and Vladimir will give you later on a little more detailed view of how the system will look like with the different foundation solutions in the training session area. So we're just moving up over there. So back again, hi. So this is already one solution how it could look like in the garden, in the field, in the farming area, with one of the foundation solutions. So we explained already what we're going through. So we have now coming up with the NREC kits 4 different solutions for any vacant of space. So we're using first a gabion. Most of you might know that or have seen that gabions are used in especially sometimes in the gardens, as well as to reinsure places where streets are running on hillsides. Then we're coming with a concrete foundation. This is known already with our NREC. So we have a stripe foundation based of concrete. We have the possibility to work with ground screws, so a screw foundation. These are longer screws which are drill down to the ground, and where we fix them systems on top. And we come up with this kit solution also with a pile solution for the kids, which is basically coming from projects. So pile is one of the majorly used foundations for projects. So this is just a profile which is ramped into the ground and ensures the stability of the system. So yeah, each and every foundation has advantages, disadvantages in the process of system, and could make more or less sense on different projects. So going through the kit configuration, as mentioned, is optimized especially for the retails also. So very easy for retailing companies to stock material and to ship them in a fast way on projects. So we have just a few items in general, 2 as mentioned, top and grounding kit. And we could have a third one, which is the foundation itself. For example, could be the gabion, or could be the screw, for example. And we have a modular designing and a well thought out documentation of the whole system. When you want to use this kit solution, first of all, it starts with which module am I using? So which type of module, and what is the size of the module? Because the kit comes in 2 versions. It's a S and an L version, so the small and the large version. Small version is using module sizes up to 1.9 meters in length and 1.15 meters and 1.15 meters in the width. And the L version is in standardly use up to 2.4 meters in length and 1.15 meters in width. So first of all, you decide for which kind of module am I using. This will give you the answer. What is the kit you're using? Are you using an S or an L version? Then there we see the sizes. Then you will think about, okay, which size am I using? So we have now 2 different sizes of tables, let's so called. So we have a 2x7 module size. That means 2 rows of modules in a portrait orientation and 7 modules in length, as well as 2x12 version. This is coming from even from the S as well as from the L version. So you decide either you want to use a small system, which could be up to 7 to 8 kilowatts, the 2x7, or using the larger one, which is then up to 12 kilowatts. But you could also combine it. So let's say if you have a larger project or a medium-sized project, you could combine it, matching the best sizes of your project. When you decide for the right top kit, then you were coming to the ground kit. And now you need to decide which kind of foundation am I want to use. So for example, I have a project inside of a garden, a small garden table, for example. I'm using a gabion solution. Why I'm using the gabion solution? Because it's pretty easy to install. You don't need any special tools to install a gabion. It's just a gather, so metal gathers that are coming together with spirals. So they're installed just by hand, let's say. And then you have the stones. So rocky stones up to a size of 120 millimeters in diameter. And the scabions are just filled with the stones. So this is quite easy, could be done by hand. Also very fast and a very easy way of installation. Or am I using a pipe, for example, because I have a ramming machine on spot, and this is a little medium-sized project. I want to have a very cost-effective solution instead of material cost. I'm using a pipe. So you decide which kind of ground kit you're using and combine it with the top kit. Depending on which top kit you have, you need to have a certain volume of ground kits. For example, we're going up here, if you're using the 2x7 NREC top kit, if you have the small one, you need 4 ground kits. If you have the large version, you need 6 ground kits. So this is the combination you're doing. And at the end, you have a finished NREC kit solution. What we also provide is we provide also the gabion itself, as well as the drilling foundation and the piles. The concrete foundations are not provided by K2, so you need to get them locally, or you will do the stripe foundation by your own with the concrete. As well as the stones for the gabions. You need to provide that also region or from your region. So here we see it as an overview. First of all, thinking about what is the module size I'm using, choosing the right NREG kit in LS or L version, then deciding which kind of length do I want to use for the system, and coming to the ground kit, deciding what should be or what is the best solution of foundation for this project. So that's really easy by just 3 steps to decide what is a matching product. And there is no designing in a tool or software needed. So this is a standardized system totally. So you get everything, and everything is designed by approximately 70% of the different project needs in terms of wind and snow load. But I'm coming later on, I'm coming to the load part. Here we have also a little overview. You see that in the general manual of the system, where you see on the left side the ground kits, the module width that could be covered here, and then the foundation type, where you also see the article number of the different kit, of the different ground kit, and you see these are the top kits and the number of ground kits you need for the different top kits. So pretty easy. Correct. So, and yes, the systems, this is the standard of the system, but you could also use the system or the top kits. For example, if you have a 1.3 meter module width, you could use it also with that kind of module width, but the table will be shorter than. Same table, but instead of 2x7 modules, for example, you will have then 2x6 modules, but that works also. So yeah, now Vladimir will show you a little bit more detailed how the construction looks like, what is the size, how does a gabion look like, and a drilling foundation, etc. So let's move over to Vladimir. So yeah, looks like we have a little. We lost Vladimir for a short second. So he might come back pretty soon.
Yeah?
There he is.
Now.
It's working now.
Thank you, Lars, for this nice and detailed explanation. So welcome back to our training center. Here I will show you our NREGs, how do they look like. Let's start with the simplest one, with the gabion. Or maybe let me start explaining what is our top kit and what is our ground kit. So top kit is the same for all type of foundations. So you will get these braces, this one and one on the back, support in the middle, and stronger brace on the top. And on top of it, you're installing cross rail 73 with 2 climbers on both sides of the cross rail. Yeah, and you input here your model and clamp it with our standard clamps. Yeah. And what is different for each type of foundation is our type of foundation kit. This one is, for example, for gabion. You see here a connection to our brace, and also a bit bigger plate here underneath of it. So the gabions, you can see is different size, smaller one in front and big one on the back side. The reason is that for the back side you need more ballast. And this is the reason for bigger gabion. So the gabions are easy installed with such, how to say it, I don't know, pins or maybe sticks. Yeah, you can see it here, it's already installed. So you must think about it. You have first to install our brace, and then you can close our gabion because it's easier to install instead of trying to reach the screws through the gabion. Yeah, installation is quite simple. You just, so to say, screw this one inside. Yeah. At the first time, maybe it's not so easy, but you will get used to it. And here is installed. Yeah, you do the same. On another side is installed, and here additional, I would say, sticks. Yeah, to connect it, they installed In this way, you just clamp it here, and you here on the opposite side, yeah, to make it fast. So to prevent that it's moving apart, having stones inside. Yeah, and you will need some of these sticks here, 4 in each corner. Yeah, so it's like connected, it's secure, so no stone will fall out. Yeah. So let us proceed with concrete foundation. So here you will see this on top is the same as for our gabion. The difference is here. You will see here a different foot. Yeah, it's a thin foot is installed with multi-monty concrete screw here inside of the concrete. So concrete we don't provide. You will need to take care locally buying such nice concrete foundation. And here on the back side, the foot is a bit bigger, yeah, with 2 connections, and yeah, it's a bit bigger. It is also with 2 multi-monty screws, but the foot doesn't have such bigger plate as we saw at Gabion. So the next one supposed to represent ramped foundation, but it's only representation because ramped foundation connection to this ramp posts isn't done by foot, but you will see. Let us show our nice ramp posts. You'll see here it's our ramp posts. It's a longer post going inside the ground, and we don't need a foot here because we have here our holes in the brace installed inside this ramp post and connected by the screws. So we don't need foot here. And the last type of foundation is our screw foundation. You can see it here. What is important to know here is about this plate to connect our structure to the screw. It's supposed to have such nice surface here with holes, so we can connect our foot to the screw. Exactly. What else is important? So probably if you are experienced installer, probably you will ask, what about clamping range, clamping area of the model manufacturer? So it's easily can be adjusted because we use here 2 climbers, and you can just install the rail higher or lower if you need it, to meet the clamping range of the model manufacturer. Another point is to say, because I had already a question in our chat, that the models are always installed portrait, so always vertically and always clamped with 2 clamps on the long side of the model. So I believe something else. Well, Lars, is something else we want to show here live?
I think at the moment not, but yeah, just maybe giving you some detailed information also on the parts, on the foot that are connected. For example, this is the one using for the gabions for sure. It's always the same in front and the bottom used for the gabions. What is important is I will show you a little together also shortly is when using the gabions, our standard measurement is a 10 times 10 one. There is working also a 10 times 5 getter for the gabions, but this is the minimum that you need to have because this one is placed over the top here on this plate. So you could imagine if it's just 50, it's working in between, but if you have a smaller gather in the gabion, it's not working. So this is the minimum. We need minimum 5 times 10. Better is using our gabions that we also provide because they're coming in 10 by 10, and just even coming back to maybe to a price issue, it's a little bit less cost effective as if you have a very shorter gather, for example. Yes, important also is if you use gabion foot, that on the back part of the coming back to the NREC, for example, if we look over here shortly, the back here is the most power of the suction force is coming up. So we will have a larger gabion in the back. The gabion in the back is up to 1 meter in height in general. So that means reaching this point for installation, be careful. Try to just not closing the back part of the gather. Just leave it open until you have installed the NREC piece in the foot and the bottom, and then you could just close it and assemble the final do the final assembling of the gabion just in the back part. The front gabion is quite lower, so you reach every part because it's kind of tricky if you need to move with your arms in between of the gather of the gabion. So this is maybe some good information. Yeah, just moving back over here. Yeah, that's fine. And what Vladi did mention is if we're using the screws, the screw foundation, it's important. We provide screws. The standardized length for this kit system is 1.3 meters. We provide earth screws from the manufacturer Kreemke earth screws. You could also use another one. What is pretty important is that the top plate of the screw where we fix this foot needs to have a diameter between two holes of 150 mils. Otherwise, our foot will not match. This is something to consider and to keep in mind. Yes, I think this is from the small parts. The connector maybe shortly. It's for everyone who knows already the NREC. This is the Crossbeth 73, which is coming with the NREC kit. The connector is just running inside of the rail profile. So just stick it in, push the other rail over the top, and then it's filled with fixed with self-tapping screws. We see those here, those self-tapping screws. We have this line here where the screws are coming. So this will guide the way of fixing this. So yeah, not a lot of things to say to this. The kit is pretty easy in assembling. So for everyone who knows already K2 parts from roofs or facade installation, he will really fast have the feeling of using an NREC on the ground, you know. So just moving back to the presentation. One advantage by using gabions also is you don't need to have a wind bracing in the back. So this is the diagonal reinforcement in the horizontal direction. This is just because the gabion in the back is pretty high, so the system is stabilized already. It doesn't need that. So this is something really an advantage. What I could tell is the advantage from gabions is it's super easy. You don't need to have any special materials. Even my kids could install a gabion. There's just also a manual for installing a gabion or a link for the installation manual of the gabion in our manual that we provide. You could use rock stones. So really not the small ones. You're using stones in the size of 100 to 150 mils in diameter. So this gives enough strength and power to hold the system on the position. But these stones are even far cheaper than the ones you normally get for the garden and you're using in the garden. So these are pre-broken stones already. So and it's easier to get them in a lower budget price if you have a machinery a site in this area where they get these stones, or as if you go to a market to buy them. I mentioned already the installation procedure with the back gabion that you need to think about. And you get also, if you want to get your own gabion, for example, depending. Ours are made of steel, galvanized steel. If you want to have a stainless steel gabion, for example, this is a project article at K2. You could get them also locally. Just keep in mind that you need to have at minimum size in the gather of 100 times 50. That's the minimum. Using concrete foundation is a very material side. From material point of view, it's a quite very low budget solution if you don't count the concrete foundation. The concrete foundation, sometimes you get them locally manufactured in fabrics. In most cases, you will make the concrete foundation locally on the point where you want to have it. That means you need to replace it. You need to have steel inside this concrete foundation. So it's not just concrete, it's also a steel concrete, and it's a C25, minimum C25 in strength. So this might need some more experience in this work, but also an easy and fast way. The only disadvantage is if you do it on site, the concrete, you need to wait until it's really sticky. That's the issue. We provide the reinforcement plan in the general manual, but you will see that later. All right, then we're coming to the earth screws, so which are just screwed into the ground. What is the advantage of a screw? It's a kind of more expensive as a standard ramming post, for example, but the advantage is screwing it to the ground is close to the same speed as using a pile, but dismounting this screw is far easier and has the same speed as the installation speed of the screw. And you could use this earth screw again for another project, for example. If you ram a pile to the ground, in most of the cases, there were damages because of some stones and rocks inside of the ground. So it's damaged. It couldn't be used a second time in most cases. And in many cases also, it's very tough to get them out of the ground, or even you don't get them out of the ground. So this is really an advantage of a screw in terms of the CO2 footprint, the carbon footprint, for example, because you could use the material again. It gives a lot of strength, and you don't need to have big machineries, for example. There are more or less three ways to install a drilling foundation. You could use a digger, a small garden digger, for example, with a drilling machine on top. This is working. It's one point of installation. You could use a kind of missing the English word, a kind of rope. It's a small machine coming like a tank, like a small tank, for example, where you have a drilling machinery on top. This is a very fast and precise way. You could rent these normally at garden architectures or even in machinery parks. It's a fast way. But if you're just installing a very small system, for example, you just have a table of 2x7 modules, you won't go this way. So what is also available is a little hand machinery. It's a kind of hand machinery where you place over the screw. It's connected to the screw. Then you have a little pile on the side, which is placed to the ground. So you get the torque onto the screw, and this could be done by hand. The procedure of drilling these screws into the ground will take per screw approximately 2.5 to 3 minutes. Which is quite a little bit longer, as if you're using a little more heavier machinery. With the heavier machinery, it's less than a minute to screw them in the ground. But a very fast and easy and a far cheaper way of machinery. So this could be rent also at machinery parks or even at Kreemke. This could be rent. So even a quite good solution, which gives you also a lot of safety. And then we have the pile-driven solution. This is coming from project business. So in most of the projects today, they are used ramming posts. So This is like a professional ramming pole. We designed it in a length, so it's coming with a 2.3-meter length from K2. And this one, yes, we always provide the piles also including in the ground kit, just because this pile is really specified for our construction, and there is no other available from any other supplier in the market. So this is always supplied by K2. And it comes in a length of 2.3 meters. That gives you approximately 1.8 to 1.9 meters of depth into the ground, because 40 to 50 centimeters will stay above the ground to connect the braces inside. This is one of the, from material side, the cost efficient solution, but you need a little bit different machinery. So for instance, you need a big ramming machine. That is one option. The other option is like you have a digger and you push it with a digger into the ground. But this is not the small garden digger. This is a little bit a heavier digger, or even using a John Deere or something to dig that to the ground. This is working also, for example. Yeah, those are the difference of the foundation types, and what are the, for example, the advantages or disadvantages, and what is better to use. Here we could see a little bit application examples for instance, like here we have an industrial building where there is still non-used area at the outside. For example, maybe the roof is already filled with a solar PV system, or we have that sometimes in the Nordics, for example, where there is no reserve of load on top of the roof. So it is not possible to install a PV system on the roof, but maybe there is area around which is not used, which is industrial area. So you could place a system also from small to medium sizes over there. And this goes pretty fast and easy with these kits, because there is no long designing process as on project business, for example. Yeah, could look like this, for example, in industrial, but also on farmlands. For example, I have chicken. From my chicken, is this, who knows about chicken? It's important that they need to have something which ensures a little bit that there are no, like for example, the chicken hawk, which is, yeah, he always takes the chicken. They need something to be to enslave them a little bit on the spot. So it could be used over there, could be used for just energy production. If you have sheeps in this farming area, you could have a double use of the land. So also a very good possibility to use solar systems. And honestly spoken, even here we see it for gardens. It's an advantage, because if you go to the building, if you need to have an installation on top of the building, you always need to think about safety, of workman safety on the site. So you need additional parts to ensure the safety of the personnel working on top of the roof. It's far easier to do the work on the ground. So there's less safety regulations and less safety processes to need to think about. So, and this saves also the cost that you have on this point on the building. So also a fast way, and the small sizes could be easily connected to the house grid connection. So also an advantage to think about, and to give the possibility. Even in the UK, for example, we have situations, there is no space on the buildings, but there is a little garden where you could place a table. They're using stuff like this since years already. Also in Denmark, I know several of projects with very small tables just for the garden, as there is no more space on the roof. So an idea to use it. All right. So are there any questions already, Vladi?
Yes, there are some good questions even. I would like to answer live.
That's cool.
For example, Noel is asking about ground installing NRAC on concrete plates or on gabions. If there is something you need to do with the ground, so it's like solid enough
Yes.
to keep the weight.
Yes, for sure. Always. Yeah. So the ground needs to be strong enough to take the forces. So you have a certain volume of force. For example, if we think about the maximum load factor, we have the foundation for gabion in the back has about approximately weight of close to 700 kilograms. So the ground needs to be sticky or strong enough to hold this load that it's not sinking into the ground. So what you need to do for sure is you need to compress, either to compress a little bit the ground and to prepare the ground. Like if you're doing walkways in your garden, for example, you take a little bit of the grass. You just cut the top layer of grass a little bit deep to the ground, like 20-30 centimeters, and you will compress a little bit the ground over there, and then you have little stones and rocks inside of that to make it, and you level that, and then on top you could place the system. So the ground for sure needs to be prepared to be strong enough to hold these forces. And it's far easier if you have already prepared ground. So on several areas you have already prepared ground which is strong enough, but to double check that.
And here's a similar question, but about our screw foundation and ramped foundation. How to check the soil? How to verify that the soil is strong enough to hold?
So what you could do by verifying the soil is you could check locally on the municipalities, or hope that's the right word. What is the standard earth condition? So because this solution is standardized, and we have that in the manual. It's written also in the manual what needs to be the ground condition. So there's a norm for this, and you could request that locally. Okay, what do we have? What do we have for ground? And if we match this condition, you could easily just use the system to install, or at least minimum this condition. Every condition which is better than this one is not any problem. What you need to consider also, and honestly spoken, for example, farmers, they know pretty exactly how their ground are look like. So they know pretty exactly, oh, do we have rocks like this inside of the ground? Or is it pretty easy? Because they're working on this ground all the time. So if there are stones and rocks like this all over the ground, yes, maybe a pile-driven system is not the best solution, for example. Yeah, and this could be checked with the customer, for example. But if we're talking about just a garden table, I wouldn't use maybe a pile-driven system in the garden. So this is where you come up with a solution with concrete foundation, or even the gabion solution, which is very, very easy and fast in that way. Even a screw, like an earth screw, this is coming pretty good towards the ground. The earth screw has a far bigger diameter as a pile. So that means all the earth is getting compressed already towards the side. So you get a very high force with the earth screws. And the earth screw really ensures you a lot of safety. So we have far enough safety factor here inside of this solution to just easily go towards the ground. As less as you're not in, it is not like a flooded, every time flooded area, let's say.
Okay, thank you, Lars. Here's another question about tilt of the system. So we can say right away that the tilt of the system is already in the
degrees.
Name. Yeah, it's already in the name of the system. So it's 20 degree. It's always 20 degree and only 20 degrees. So you cannot adjust it. It's always the same tilt.
Yeah. And it's a quite good matching tilt in most cases. And at the end, you need sometimes to think about where I'm using. If you're having a project, let's say a size of 500, 700 kilowatt, it totally makes sense to make very specific designings. But coming back to very small sizes, where we're talking about maybe just a small garden table or 30, 50 kilowatt system, doing all this customization just for small projects is this super heavy in terms of time that you spend in all the designing processes, as well as more expensive in material because this is something designed just for this project. And yes, 50K, for example, is very small in terms of a ground system.
Another question is about installing on sloped terrain.
On slope terrain. Yeah,
Yeah,
let's
if
say
it's not pitched.
we so if the terrain is, let's say, about up to 7-8 degrees of certain slope of terrain, this could be installed quite easy. It's just running with the terrain. But if we are really in a sloped terrain like 20 degrees, for example, a little hilly side or something like this, no, the systems are not designed for this kind of use. We have a system that is working in the in Switzerland, Austria, as well as in Germany. That will work also for other countries. For instance, it's just a kind of tricky to get it's a solution with a screw, and it's not that easy to get those screws outside of Austria or Switzerland. So you need to get those screws then from Austria or from Switzerland to the country where you're working with. But yeah, we know that we have also the utilization on hillsides, and maybe we come up in the sooner future with a solution also for this stuff. Vladi, there is a
Thank
live
you.
question.
Yeah, there are many questions marked by me as live questions. So in another one about road distance. Do we know what is the perfect road distance between the entry kits?
The road distance does always depend where you are on the equator, let's say. You could design that and you could and even do you want to plan with a part-time shadow or with non-part-time shadows? So this is something specific where you need to check, for instance, with a tool like PVSol, for example, you could, or PVSys or something, you could check what is the optimal road distance. I'm pretty sure you will find also easy tools in the web. Just hey, what is exact or the best road distance by having this side of a system pitched by 20 degrees in this area on the world. So check that over tools like PVSol, PVSys or anything, or check it just by the web. It gives you definitely an answer. But yeah, this is standardized. So, and you could easily check this by the web based on your area where you're working with. El Hardy?
There are some questions which are really related to assembly instructions, so you will show later.
Yeah.
And explain everything. So
we go over the assembly
about
instruction. I think there's
exactly,
a lot of answers inside of this.
Yeah,
but
yeah.
maybe
about
there is
about the wind loads, snow loads, yeah, weights.
There is a live question.
Forces.
There is a
so
real
everything
live question. Vladimir, there is a real live question
El Hardy.
from El Hardy.
Okay. You can speak now.
So El Hardy, you can speak now.
Hat das Mikrofon schon angehabt? Mikrofon was open, but
microphone was open already. Hello?
Things. It doesn't work? Or
doesn't work. It depends.
Don't like to say anything. Okay.
Could be that it doesn't work, or otherwise maybe just write it down in the Q&As, and we will also answer afterwards of this session questions. All right. So Vladimir, I will go over now to go inside of the menu, give an idea of that.
Yeah, exactly, exactly. Because I think some of the questions will be answered showing assembly instructions.
Yeah, need to check it over here. Right. So here we have the manual, and as mentioned, this time it's a little bit heavier manual. So I recommend if you go to our product catalog, just download it one time, because it's coming also with with data sheets of the different kit solutions. That's why it's also in size a little bit heavier, let's say. We're working to compress it a little bit. But yeah, actually at the moment, I would recommend just download it one time, or just even open it and make a PDF print just on the parts that you need is also possible. So if you're running on a certain project where you just want to use, for example, a concrete foundation, just print out in PDF the pages that you need, for example. Then it's getting a little bit shorter and it's easier to send it then also via email. All right. Yeah, you see it over here, the content, it's kind of, wow, impressing content, but at the end, it's always a combination of certain points that you will use, and this is why it's getting shorter than when you use it. We have always, like always, the main tools needed, general safety informations. Here are some guidelines that apply, important in the assembly. What frame heights will work, some static informations also. They're coming also on the pages of the different foundations. There are certain very specific general information about this part. Here we have the list, for example, with the support forces, you know. So we have several different kit solutions, and so 2x7 small and large, as well as 2x12. We have the different size of the modules, and here we see what are the maximum designed load combination forces. This is pretty important for you to remember. This is the extreme forces in combination. So that means there is a combination of a snow load of 1.75 kilonewtons and a wind load of 0.67 kilonewtons working together. So in combination, then combining these forces, we will have at max these support forces in uplifting, in vertical pressure, and in horizontal forces on the different systems. So whenever you want to use, for example, a concrete foundation or your own drilling foundation or the pile, and just in general, without calculating and redesigning anything, you should ensure that your foundation could withstand the forces shown in this page, for example. So then we're coming to the top kits and to the bottom, to the ground kits. Here in the top kits, we see which parts are belonging inside of the top kit. So we see the braces of the rack, the beam of the rack, the rail profiles, and module middle and end clamps. We have here this list showing the different top kits and the value or the number of ground kits needed per top kit. Of the different ones, and here we see the 4 different ground kits and what the ground kit does consider. So we see for the gabions, the ground kit considers the climbers, the screws to fit the rack towards the foot, the connection foot, and the connection foot. Same for concrete and for screw foundations. At least there is a difference for the pile-driven solution. In the pile-driven solution, also the pile itself will come with this ground kit. For the other solutions, for gabions and ground screws, we provide and we offer also gabions and the screws in general, but they're not combined already in the kits. And this is a kind of the reason why we didn't combine them already in the kit is if you think about just this plate and the screws climber, it's just a small package. But on the gabion, for example, on the back gabion, we have 1.1 meter piece. And if we want to combine this in this kit, in this ground kit, will mean that you have, or even the resellers, they will have a lot of several pallet spaces. And this is honestly spoken, having a view or reviewing the carbon footprint that doesn't make sense. That's why we put them out and why we provide them separately. But you find also the article codes for these pieces later in the pages. And the same for the earth screws, just to remind. Here we have a list of the articles on top kits, small parts in the top kits. Here we have the article list of the ground kits again, where you see piece by piece, and then we're coming to the pre-assembly of the module supports or the racks itself. So we see which pieces are needed to pre-assemble those racks, because you could pre-assemble them. It's not that you install the ground kit and fix the foot for the ground kit and you install piece by piece of the braces. No, you pre-assemble this rack, and this rack will then placed into the foot and connect to the foot. Yeah, and then we start with the gabions, and here it is written also what the soil requirements. So you find the soil requirement written over here also. Again, the tools that are needed, and here you see the 2 different gabions that we provide that you could also order via K2 or via the distributor. Here is the link to the installation manual of a gabion. Maybe shortly shown over here, where you see how it is connected together, all these pieces, also the distance brackets, how they will be installed, and these parts, just to ensure that the gabion is installed correctly. Now I need to switch back here. All right. Too fast. Yeah. Then you see the installation process, so preparing those pieces, bringing the plates on the right position, placing the gabions over the top. Here, you please consider that for the bigger gabion, just leave one side, at best at the back, open to install first the end rack, so the rack itself, and then close the gabion. Still working afterwards, but with a little bit more trick. It's a little bit more tricky. Then, installing the racks, fulfilling the stone, the racks, and then you could go on with installation of rail profiles, modules, etc. pp. Here, same for the concrete foundation. Also here's the information for the ground requirements, the soil requirements. And if you look to this norm, it will explain you, okay, what or how you need to handle the ground and the soil over there. Some structural requirements or the brackets. Here we see how the stripe foundations should be prepared. For example, also with the reinforcement, with the steel, how it should be designed, the drilling holes for the foot, etc. Everything is shown over here. So either you do them locally, directly on site, those stripe foundation, or you have a company providing those or pre-done in the fabric, prefabricated, for example. So yeah, same over here. Then installing all the rest of the material. Screw foundation, right? Similar here. You see a little bit. This is the hand machine here, this one, and this is a kind of caterpillar that you could easily rent also to install those earth screws. Here is also the article code for the screw foundation that we provide. If you use a different manufacturer from anywhere, just consider that the plate on top needs to have a diameter between 2 parallel holes of 150 mils. Right. Installation manual, how it's done, and all these measurements here in the installation manual, they are shown in the data sheets following in the last pages. So this is just in general. And here we see the ramming foundation, how it's working with the ramming foundation, what machinery could be used for ramming posts. Correct. Then we're coming to the part with the rail installation, and we recommend installing the modules from the center, so from the middle to the outside. Why? Because this is a standardized kit solution. That means the rails having always the same size, but you could install module width from 1.38 mils up to 1.150 mils. But that means also when you just start from, which is mainly done on the roof, for example, starting on one side, then you will end up, especially if you're using 1.038 mil modules, with just a lot of rail profile at the end or as an overhang, and you need to cut that at the end. And it's, let's say, it's not that from the optical aspect, maybe it doesn't look that nice as if you start from the middle, you have the same overhanging at both ends, and you could cut it or leave it, but it looks then totally same, so symmetrically on both sides. So this is why we recommend to doing it like this. Here we see how a wind bracing is set it up. As mentioned, with gabions, you don't need to use that. It's just used on concrete, screw and pile foundations. Right. And then we're coming directly to the different system data sheets. And in all those data sheets, depending of, here we have the 2x7S, you have all the important information. What total rail length do you have? What is the distance between the center of the gabion foots, let's say, how to place them, what's the distance in this direction of the braces in the foot, etc. So you get all the important measures and informations over here, same as well as the article parts here shown over here. And this is done for all the different kits in the small and long version. So, back here. So Vladimir, any more questions right now that needs to be answered?
Here's another question about structural question about forces of our rammed posts. Do we know what is the force of our rammed posts being rammed into the ground?
As mentioned,
I hoped it's in assembly instructions, but I didn't see it.
Is as long as if the ground is rammable and it fulfills the conditions that we shown in the manual, we have then it's oversized. It's oversized. And yes, if you want to have a standardized system, you need to oversize. That means if we compare this ramming post to projects designings, it's oversized. In projects, we have shorter ones, or especially we have longer distance between piles. So here, this is the way how we ensure that the system is working, even if you do not have all these soil testings. Because honestly spoken, yes, if you're doing project business, you will have soil testing, pull-out tests, and all this stuff which guides to additional costs. You cannot spend these additional costs. For example, if you want to set up a 20K system, so 20 kilowatts, you don't do this. So we have a lot of safety inside of the pile solution, but it's still a very cost effective and more cost effective compared to the other solutions. That could be said. But yes, there is also a general ground condition for this that you need to provide.
Okay, thank you, Lars. So we have no open questions.
All right.
By now,
so
right on time, I would say.
Okay, so I just want to add then, this is a standardized system, but that doesn't mean, and there are several standardized, let's say, measures as well as values coming with this system from the general menu. For example, the wind and the snow load, where it's designed for. You might have a project which is not based on an alpine region where you don't have 1.75 kilonewtons, you have 4 kilonewtons of snow load. Doesn't mean that this kit is not working over there. It means we need to double check that with us, because in that case, we might say, yeah, use that kit, but you will need additional racks, for example, and additional piles, for example, to install that. That means the distance of the racks is reduced to fulfill the stronger loads that you have. Same, for instance, if your wind loads are far higher, but the snow load is far lower, for example. we have already checked this for the UK market, for example. In the UK, the wind forces are higher than the ones that we designed here in the general manual, but the snow forces are lower. And yes, we could say this system is working in the same, more or less in the totally same way of material like in the general manual. The only difference is there's a little bit more ballast needed. So by using a gabion or concrete, the foundation is getting a little bit more heavier to fulfill. But we know, for example, the drilling foundation is working totally in the same way, because the drilling foundation, the pile foundation, is oversized to these loads. So there's a question I will answer pretty shortly. The chat.
Feel free.
There's a question in the chat. Maybe you could check that, Vladimir. On the other hand, also module sizes. Yes, the kit, for example, with 2x7 modules or 2x12 modules, it's designed up to a module width of maximum 1.15 meter. That doesn't mean that 1.3 meter doesn't work on this kit, but you will lose a module. For example, if you're using the 2x7 kit and you want to have a 1.3 meter module width, it's just a 2.2 times 6 modules table then. The 2x12 modules table is reduced then to 2x10 modules. This is the only thing that will change. For instance, the loads that are working on the system are more or less very similar, because the surface of load, where the load is working, the wind and snow load is working, doesn't change a lot. Oh, now we have the question. We found the question.
Oh yeah.
We have money. The question is if you want to consider a 2x24 kit as well. I mean, 2x24 is 2x12, but with 2.38 meters, it's 2x10. So we could say you use 3 times the table of 2x7 modules, because this will be reduced to 2x6 then, if by using the 2.38 meter module. And if you're using 3 times this kit, you have the 24. So you have 2x24 modules then in total. Considering if you have a table, the thermal gap between a table, between 2 rails on the same position of 2 different tables, should be at least 6 centimeters. This will cover a thermal expansion of by a temperature difference of 80 degrees, for example. So this is how it could work. And yes, we are working, as the general manual is designed like a general manual, and there are just additional data sheets, for instance, needed. Yes, we are already preparing different kits for different markets, because the 2x7 and the 2x12, they're designed pretty, let's say, pretty in the Austrian, Swiss, German, even a little bit UK designing. But we have different markets where we have also different table requirements. And yeah, we're working already on additional product data sheets for bigger tables, for example.
Yeah. Here's another question about Karina ground screw. If it always comes with this plate, or is here a special parts code?
With the part code in our manual, they come always with this plate. Yes, this is the one we have in stock in general, and which we are using with those kit systems. If we are running in project business, we are using a project-based drilling foundation. It's something totally different. And then, for example, everything could be different to the one that we're using in standard. Even also the kind of fixation to the screws could be different. Then this is something project based. But in general, yes, this plate is always the same for the kids. Right.
So okay.
So
No further
if there
questions.
is no more questions, great to have you here. That you joined us. The presentation and more information will come afterwards of this little presentation, and follow up in the mail, I think, Klaus, right? So you get more infos, more input over there, getting all the different stuff that we've shown here. And yeah, I think if you have any more questions or anything, just feel free to contact directly K2 Systems or even your distribution partner in the country to get the information needed. Yeah, it was great to have you here.
Yep.
Hope to see you
Thank
soon.
you, Lars.
Yeah, and from my side, I say goodbye. So, Vladi,
Yeah.
you have the last word.
Thank you, Lars. Say thanks, team, for this webinar. So maybe one more information from my side. At this moment, assembly instructions in English language are not available on our webpage, but they will follow, I would say, within 1 week. So at this moment, only in German available, but it will come also in English. So you will be able to find it in our product catalog. Thank you all for joining us in this webinar. Next week, we will talk about flex adapter, also new solution, nice solution, especially for tile imitating sheet, in East European countries, very common. So I hope see you next week.
Take care. Bye bye.
Bye bye.